All right, this is your lesson on solving log equations. Okay, in this lesson you will solve simple exponential and logarithmic equations. Basically, you'll be solving an equation like this where the exponent is the unknown. Okay, this is one of the techniques that we can use to find the exponent. We don't know what that is. All right, let's talk about how we use these notations. Here's the log of something, right? Common log base 10 of something. Then the anti-log for that would be just 10 to that something. And these two will cancel each other out. The cancellation occurs in this case, and that actually becomes 1 here. Okay, or you can reverse it around and they still cancel each other and become 1. So both of these are equal to 5. Alright, and if you have a log base 6, the anti-log would be 6 as the base, and then you have the exponent. So either of these would be x, because the log base 6 of the anti-log of base 6, or the anti-log of base 6, to the log base 6, they cancel each other out and become 1. They don't become 0. Okay. Natural log, the anti-log would be the e. Okay, this is the anti-log of the natural log. And then these cancel out, and those cancel out, just like the other notations that we've been using here. All right. We're going to watch me do this one, and you'll do this one. Okay. So first, we're going to use our log, and as long as we're doing the same thing to both sides, we can use any log that you want. And I just like writing ln instead of log, just one less letter for me to write. So I'm going to take the natural log of both sides. That allows me to bring the x out of the exponent position. And then I'm going to divide both sides by natural log of 2 to get x by itself. And those cancel. And then I have this. And then you can finish this off with your calculator and you should get 5. Okay, you do this one. Pause it, come back, and see if you did it right. Okay, following all the same steps, you should get 5. Next. Okay, you're going to watch me do this one. I'm solving for x, so I need to isolate the x. So I'm going to go ahead and add 3 natural log of 3 to both sides. So now I have natural log of x is equal to natural log of 3. And then here I'm going to take the anti-natural log of both sides. They cancel each other out. I get x is equal to 3. Okay, go ahead and do that. You finished? All right. Answer should be x is equal to 6. Okay, next. Watch me do this. This is basically the same problem as we just did before. We're going to take the natural log of both sides. And then we can move the x to the front. Divide both sides by the natural log of 1/3. And finishing this off with my calculator, I get -2. Following the same steps on this side. You finished? Okay. Then I get that. And the final answer is -5.129. Okay, watch me do this side here. You're going to do the log of both sides to cancel the anti-log. Bring the x to the front, and or just cancel the natural log and the anti-log, and you get natural log of 7. Okay, do these two. When you finish, unpause it. All right, if you take the natural log of both sides, you should get x is equal to natural log of 8. Okay, now you do the same thing with this one, except now it's a little bit in reverse. You finished? All right. So you're going to take the antilog of both sides, cancel that. You get x is equal to e to the negative 3. Okay, continuing here. This is the same thing as the last one, basically. Take the antilog of both sides, and I get x is equal to 10 to the negative 1, or 1/10, because this negative sign means to put that in the denominator. Okay, you do these two, all right? Finished? All right, so you take the antilog of both sides, and you get x is equal to 8. Take the antilog of both sides, and you get 4 to the negative 3. We don't write answers with a negative exponent, so you have to put the 4 in the right place, which is in the denominator. And then we can finish this off definitely. 4 times 4 times 4 is 64, so this will be 1 over 64. Hope you're doing well so far. Watch me do this one here. We're isolating x, so using some algebra, you're going to undo all of this by dividing by 3 on both sides. Cancel that out, and you get 2 to the x is equal to 14. Now you're just going to use a log function to bring that out of the exponent. Divide both sides by a natural log of 2, cancel that, and you get x is approximately 3.807. Now you finish this one. Okay, are you done? All right, so divide both sides by 4, and you get this. Take the natural log both sides, move the x to the front, and divide by natural log of 3, 2.402. I hope you're doing well. Okay, all right. Next, just added one more step. I'm kind of extending this a little bit, adding one more step or combining some steps that we've done before. So we have negative 3. We're trying to get the x by itself. So first we're going to get rid of that negative 3. We're going to add 3 to both sides. Ooh, that's a curly 3. 4e to the 2x is equal to 5. What should I do next? How about divide by 4? Okay, now it's starting to look like the problems we were just doing. Okay. Now, to get rid of that e, we're going to get rid of an antilog. We're going to do the natural log. So now I have 2x is equal to the natural log of 5/4. Divide by 2. And my final answer is approximately, finishing this off with my calculator, about 1.11. Actually, that's a 2 rounding it off to 3 decimal places. Try and give me 3 decimal places all the time on these log equations. Okay. All right, next. Okay. See if you can work through this one yourself. Pause it. And if you get stuck, you can watch little pieces of it. But try and get the answer before you see me do it, okay? It's kind of like a competition between you and I, all right? Or at least the video anyway. See if you can get the answer before you see it happen. All right, here we go. At 4, we get a 15. Now, divide by 2. At any point where you think, oh, I can finish this, then you need to pause it, okay? Now, I'm going to take the natural log so I can get this to the front, okay? Natural log. So now I have 2t minus 5. All of that times the natural log of 3 is equal to the natural log of 15 over 2. Divide both sides by natural log of 3, And that's going to give me 2t minus 5 is equal to natural log of 15 over 2. Okay, notice what I'm doing here. I'm doing all the work, getting all the way down to t before I reach for my calculator, because if you do all these little steps on your calculator, you're probably going to make a mistake by switching over from calculator to algebra to calculator. Also, you're adding a little bit of rounding error every time you do this, whereas if you put it all at once on your calculator, the rounding error will be just at the very end. Okay, so here we go. Finishing this off, I get 2t is equal to, add the 5, so there's a natural log of 15 over 2, all over natural log of 3 plus 5. Divide everything by 2. And then I get approximately 3.417. Okay, if you didn't get this, then you probably just not using your calculator properly. Depending on the way your calculator works, you might have to tell it to do the order of operations. It might have done them out of order, so you need to put parentheses around all these things here. Alright, without those parentheses, your calculator may not know how to do this. Or maybe it does. If you put it in and you got this answer, then you're using your calculator properly. If you didn't, then make sure you put these parentheses so it does this first, then does these two logs, and then divide, and then add the 5, and then divide by 2. Okay? You have to tell it what order you want to do things in. Alright, next problem. Okay. I believe you can solve this on your own. This is kind of a simple one compared to the one we just did. Alright, here we go. Ready? Done? Alright, anti-log of the natural log. Divide by 3. X is equal to e squared over 3. And then you can finish that off with your calculator. And I get x is approximated to 2.463. Alright. Okay, they're going to look a little bit longer now. Alright. This is not that bad, right? Just a lot of symbols here. How do you get rid of this log base 3 anti-log? And I'm sure you can finish this one now, okay? So, you're done. Okay, let's see. 5x minus 1 is equal to x plus 7. Subtract the x, add the 1. And I get 4x is equal to 8. X is equal to 2. Alright, for something that looked kind of ugly at the beginning, it sure kind of cleaned up very nicely. Okay, I'm sure you can do this one too. This is just backwards from the one we just did. But you finished? Alright, let's try this here. Since I want to do the x by itself, let's subtract the 5, and I get negative 1. Divide by 2. Natural log of x is equal to negative 1/2. And then x is equal to approximately 0.607 rounded. Okay, all right. Okay, you do this one. All right, here we go. Let's try that. Natural log, log base 5 is equal to 2. Anti-log base 5. I get 3x is equal to 25. Divide by 3. And x is equal to 25 over 3. I like improper fractions. Okay. Oh, wow. Okay. On this one, you're going to, well, I'm not going to say anything until you try it. All right. If you don't know what to do first, I'll tell you now. So, unless you don't want to hear it. Okay, you're going to condense. Since this is an addition of two logs, we're going to condense this. So this is going to be x minus 2 times 2x minus 3. And then I'm going to put this on there so I can get the log to look like that. Do the anti-natural log of both sides. Alright, now I end up with a quadratic. I have an x squared on this side and x squared on this side, and the only way I can solve a quadratic is if I make it equal to 0. So I'm going to have to FOIL this out. Normally we don't FOIL things out unless we have to, but since we're solving for x, we have to FOIL this out and find out what x is. So FOILing this out, I get 2x squared minus 3x minus 4x plus 6 is equal to x squared. Eliminate the x squared, make it equal to 0. That's how we solve all quadratics. We can't even use the quadratic formula if it's not equal to 0. So x squared minus 7x plus 6 is equal to 0. And that's luckily factorable. No quadratic formula this time. Okay, so this will be x minus 6, x minus 1. So x is equal to 1 and 6. All right. You think that's the answer? There's something tricky going on here. There's an extraneous answer. All right. Extraneous means that it can't happen. So you're going to have to plug these numbers back in to make sure they work. If I put a 1 here, that's okay. 1 here, 2 times 1 minus 3. Uh-oh, we have a negative number. We cannot ever take a log of a negative number. And even here, 1 minus 2, that's a negative 1. That does not work. But the 6 is okay. 6 minus 2 is positive. 2 times 6 minus 3, that's positive. That's a 6, log of 6, that's positive. This is not a good answer. So only x is equal to 6. Okay, remember to check for your extraneous answers. Even though you did everything right, you got the 1, but the 1 does not work. All right. Okay. Next. All right, this is the last one. And hopefully you can see this as a quadratic. Do you see that as a quadratic? If you squint, maybe? Or maybe if you use a little crutch by thinking of another variable is equal to e to the x. This part right there will be the other variable. Now do you see the quadratic? It's n squared minus 3n plus 2. That's your quadratic, and that's factorable. Or you can use the quadratic formula or whatever, right? So if you're having trouble with this, use this little crutch. If you can see it, then you don't need this little crutch for now. This are like training wheels. Eventually, I'm hoping that you won't have to do this. And don't worry if this looks very, very confusing to you. This is the way it's going to look almost exactly on your test and your quiz. So if you just know how to do this one, you'll be fine. So now this is going to be n squared minus 3n plus 2 is factorable to n minus 2n minus 1, but n is really e to the x. Alright, and using the zero product property, you split this up and you get e to the x minus 2 is equal to 0, and e to the x minus 1 is equal to 0. Okay, each one of these, because either one of these, if they're 0, the whole thing will be 0. Adding the 2 to both sides, e to the x is equal to 2. Add the 1 to both sides, e to the x is equal to 1. Take the natural log to cancel the e. x is equal to the natural log of 2. Okay, and there's no logs up here to check for extraneous answers. If the problem started with a log, then I would definitely take my answers and going back in and make sure they work. All right, don't forget to do the Google form.